Hey guys, it's Professor Floyd here again, and we're going to go over homework 7 for OEH 5723. And number 1, we're asking for the pH of a 5% cyanoacetic acid solution. So I go ahead and provide to you the things that are written on the board. The molecular weight is 85.06 grams per mole, and the pKa is 2.45. So this is the structure of our molecule. We have our cyanide group, and then we have our carboxylic group over here. And then just to refresh you that the pKa is also equal to the negative log of the Ka, and this is the value. And so you can't calculate this using the pKa. You've got to calculate what the actual Ka is. And so we say the log of the Ka is equal to minus 2.45. Just move my negative over, multiply by -1, and then raise each 10 to the power. And so your calculator probably has a 10 to the power button. I like using this old calculator, and it's the inverse log button. And so anyhow, we do 2.45 negative, and then just e to the 10x. And so we end up that the Ka .00355. So that's the only thing that's tricky about this. Otherwise, this is just basic acid-base equilibria. And so to build up these things, though, our Ka is the equilibria of our products over reactants. So since this is a weak acid, our products are ionized or hydronium and cyanoacetate, which I'm just going to call A-, and then our weak acid, our cyanoacetic acid, which we'll just call HA for our generic term for the weak acid. And so for the fact that our Ka is equal to 0.00355, it means that our products are not heavily favored, but compared to other weak acids, this is really heavily favored. This is just not a strong acid. Alright, so in this problem, we want to know what is the pH. So of course pH is the negative log of the hydrogen ion concentration. So we want to know this, and we're given this, and we're told that we have a 5% solution. So we have to calculate this concentration. So 5% solution, if we assume 1 liter, then we have 1 kilogram per, this 5% by weight of a solution of cyanoacetic acid, 1 kilogram per liter. So this comes out to 0.05 kilograms, which is equal to 50 grams of cyanoacetic acid. So our 50 grams, 1 mole per 85.06 grams. And again, this was assuming 1 liter, so it's 50 grams in 1 liter. This comes out to 50 divided by 85.06. So 0.588 moles per 1 liter, which is also molar, 0.588 molar. Alright, so that is our concentration here. So what we know from this equation, since we're starting with our weak acid, and it's otherwise just distilled water there's no buffers or anything present, then for every dissociation we're going to have one acid form and one anion form. So these two are going to be equal to each other. And so the way we're going to find our hydrogen ion concentration is just recognizing that this concentration is equal to this concentration, and just call it H, hydrogen ion concentration squared. Alright, so we have H plus squared, since H plus and A minus are equal to each other, and that equals our Ka multiplied by our HA. Right? We are given this value, we're given that value, 0.00355 times 0.588, and then we want to take the square root. So that we get rid of our square. And so our H plus is equal to this. Which should be 0.046 molar. And so our pH is just the negative log of that, so we just take the log and then make it negative, and it should be 1.35, 1.34. Okay, so there you have it.